In this video we are going looking at area of figures, where we're going to be converting shapes or figures into other shapes of equal area. Looking at my page, I have set up a number of different figures. I have a parallelogram, I have 1, 2, 3, 4 triangles, and finally a rectangle. All of these, the dimensions are entirely up to yourself. Try have all of the triangles scalene, and then rectangle as a rectangle. So what we're going to look at first is converting a parallelogram into a rectangle of the same area. This one up here. So to do this, we are going to first divide this up, and this area here creates a triangle within our parallelogram. And what we're going to do is we're going to take this triangle, move it from this position, and put it on over here. So we're going to add on this piece of the triangle onto this, the opposite end of the parallelogram. So shading this in, this is the same triangle, as it has the same height. It's parallelogram, so this distance from here to here and here to here are the same. So between my pink lines, so from here to here, this is an area that is an area of a rectangle that's equal in area to the parallelogram. For our second shape, we are converting a triangle into another triangle of equal area. And before we start that, we're just going to have a look at the formula for a triangle. So in maths, if we were to calculate the area of a triangle, our formula would be a half multiplied by the base multiplied by the perpendicular height. Half multiplied by the base by the perpendicular height. In a triangle, the perpendicular height is the height from the apex to the base, the vertical height. So this green line here, that is the perpendicular height. So if we were to create a triangle that's equal in area to this one, we need this formula to stay the same. So the half, that's going to be the same, that's constant. The base, if we keep the same base, we can create a triangle of equal area. And if we keep the same perpendicular height. So to do this, we're going to create a line that is parallel to the base through the apex. Now, no matter where I pick on this line, so if I pick this point here and join that down to the base, each corner of the base, I will have a triangle with this half as constant at the same base and the same perpendicular height. So picking that point from here down to the base, this pink triangle now has the same area as the pencil one, as it has the same base and its perpendicular height is the same. If I were to draw another one, do one picking a point off of it over here, from this point back to there, back down to the base. This the blue triangle also has the same area as the pink one and the pencil one. It sits on the same base, and the height, its perpendicular height, distance from here down to here, is the same. For our third figure that we are looking at, we're going to convert a triangle to an isosceles triangle. So this is a scalene triangle. I want an isosceles triangle that's the same area as this one. We're going to use a similar idea to what we have here. So we have our top line, so that's if we keep our perpendicular height the same. So our question here is much the same as what it was in the previous one, except there's an extra condition attached to it. So I could draw a line from here down to here. I could create a triangle this way, and that will give me a triangle equal in area. However, it does not give me an isosceles triangle that's equal in area. So I need an isosceles triangle that is the same area here. So what I'm going to do is I'm going to bisect the base. Because if I bisect the base and draw a line up, the distance from it'll intersect up here. I'll bisect it first. So I have now bisected the base, and this point is now equal distance from here and here. Because I've split this in half, and this is these lines are parallel, this point is going to be the equal distance from both this point and from this point on the base. If you want, you can check it with your compass. So check the distance there, same distance over here. So this point up on top now, if I use just to draw from here to the top and back down to the base on the other side, I've created a triangle that is equal in area, but it is an isosceles triangle. So this side and this side are equal in length. For our fourth area, we're going to convert a triangle into a right angle triangle of equal area. So again, we're going to follow the same principle that we used over here. If we keep the perpendicular height the same, then anywhere on that line we can create a triangle that is equal in area. So anywhere, if I put the apex anywhere along that line, if I put it here, I can create a triangle that is equal in area to this one. But I need a right angle triangle. So a right angle triangle has a 90-degree angle in one of the corners. So I can pick either this side or this side, and I'm going to create a 90-degree angle between the base and this vertex here. So 90-degree angle here between the pink line and the base. If I join this point back to the opposite side of the base, this is now a right angle triangle equal in area. So my perpendicular height between the apex here and the base and the apex here and the base is the same. The base is the same, and half is a constant. So I've created a right angle triangle here that's equal in area. You could just as easily draw your vertical line from this point and come back down that way. There's an alternative method for doing this, and we'll look at that in a later video. The fifth one that we're going to look at is a triangle to a rectangle, and then rectangle to triangle. For this, we need to figure out the difference between our formulas. So for a triangle, our formula is half times the base times the perpendicular height. For a rectangle, our formula is going to be the base times the perpendicular height. Oftentimes we just call it the height, but it is the perpendicular height as it's a 90-degree bend. So the only difference here is the half. So the base is the same, perpendicular height is the same, the half is different. So what we can do is we can half one of our dimensions. So if we keep our base, if we half the perpendicular height, I can create a triangle, a rectangle, equal in area to this triangle. So we'll mark our perpendicular height. And we already have the base. So if I bisect the height, half, and half. So I've now introduced half into my formula. So my rectangle that I'm looking for, keeping the base the same, I've halved the height, and this pink area here now is a rectangle equal in area. So this rectangle is equal in area to the triangle, because half the height times the base times the perpendicular is going to give me my solution. Doing the opposite in effect here. This is half, if this is my height, to get a triangle of equal area, I need to double that height. So I just copy the height here and double it. And anywhere on that line, so I can pick this point here, and join that back to the base. This point, join back to the base. That gives me a triangle that is equal in area to this rectangle. It also works, I could pick a point off over here. There's multiple solutions to this one. The blue one is also the same. I can also go anywhere out here. So this one to point way out here on the side, back in, this is also equal in area.